scalar data types in Rust. What are the four main types of single values in Rust, and which kind of number does Rust use by default? Rust has four main types for single values. They are integers for whole numbers, floating point numbers for decimals, Booleans for true or false values, and characters for single letters. The default integer type in Rust is I32, and the default decimal type is F64. What is the difference between signed and unsigned integers in Rust? Signed integers, which start with the letter I, can store both positive and negative numbers. Unsigned integers, which start with the letter U, can only store positive numbers and 0, but they can hold larger positive numbers than signed integers of the same size. The types isize and usize are special because their size depends on your computer's architecture. On a 64-bit system, they are 64 bits, and on a 32-bit system, they are 32 bits. How can you write numbers in different ways in Rust, like using underscores or different bases? In Rust, you can write numbers in several ways. You can use underscores to make long numbers easier to read, like 98 underscore 222. You can also write numbers in hexadecimal, which starts with 0x, in octal, which starts with 0O, and in binary, which starts with 0b. There is also a special way to write a single byte character, like B capital A. Finally, you can add the type directly to the number, like 42U8, for an unsigned 8-bit integer. What happens when a number gets too big for its type in Rust, and how can you handle it safely? What happens depends on how you compiled your program. When you build in debug mode for testing, Rust will stop the program with an error if a number overflows. When you build in release mode for your finished program, Rust will let the number wrap around to 0 instead of crashing. If you want more control, Rust gives you special methods. Wrapping add lets the number wrap around. Checked add returns a special value meaning none if overflow happens. Saturating add stops at the highest or lowest number without going over. And overflowing add tells you both the result and whether overflow happened. What kinds of helpful things can you do with numbers in Rust using their built-in methods? Rust gives you many useful methods to work with numbers. You can find the absolute value of a number, raise a number to a power, or find the largest or smallest between two numbers. The clamp method lets you keep a number within a certain range. You can also count how many zeros or ones are in the binary form of a number. And for working with data at the byte level, you can convert between numbers and arrays of bytes, which is important for certain kinds of programming. You can use the as keyword to cast between integer types. It will never cause an error, but it might change the value by cutting it down to fit the new size. For example, a large number cast to a smaller type will wrap around. For better safety, you should use the try from method. This returns a result that tells you if the conversion was successful or not, because the number might be too big for the new type. There's also the from method, but it only works when the conversion is guaranteed to be lossless, like going from a smaller type to a larger one. What are some common mistakes when using integers in Rust? A few common mistakes with integers in Rust. First, they try to use an I32 to access an item in a list, but Rust requires the index to be the usize type. Second, they subtract with unsigned numbers without checking if the result might go below 0, which causes an error. Third, they expect integer division to always round down, but Rust actually rounds towards 0 for negative numbers. Finally, they forget that if you just write a number like 42, Rust assumes it's the I32 type, which can cause problems when you need a different integer type. What's the difference between F32 and F64 in Rust, and which one is used by default? The main difference is precision and size. F32 uses 32 bits and gives you about 7 decimal digits of precision. F64 uses 64 bits and gives you about 15 to 16 decimal digits of precision. On modern computers, both are similar in speed, and sometimes F64 is even faster. Rust uses F64 as the default for decimal numbers because the extra precision is usually worth it. You can still use F32 if you need it by writing the type explicitly. Question. In Rust, how do basic arithmetic operations work with floating point numbers? In Rust, you can do basic arithmetic with floating point numbers using simple operators. You use plus for addition, minus for subtraction, star for multiplication, slash for division, and percent for remainder. All numbers in the example are written with 0.0, so Rust knows they are floating point values. The result of each operation is also a floating point number, and you can print them using println to see the results. Question. What are NaN and Infinity in Rust, and how do you check for them? In Rust, NaN means not a number, and happens when you do something like 0 divided by 0. The tricky thing about NaN is that it never equals itself. So if you try to compare two NaN values, they will always be false. To check if something is NaN, you must use the is_NaN method. Infinity comes from dividing a number by 0. You can get positive infinity or negative infinity. Rust has methods like isInfinite to check for infinity and isFinite to check if a number is normal. There are also special numbers called subnormal that are very close to 0, and you can check if a number is normal with the isNormal method. Question. What are some useful methods for working with decimal numbers in Rust? Rust provides many useful methods for working with decimal numbers. You can get the absolute value of a number, round it down, round it up, or round it to the nearest whole number. You can also get the whole number part and the fractional part separately. For math operations, you can find the square root, cube root, and raise numbers to powers. You can also use exponential and logarithm functions with base 10, base 2, or the natural base e. Question. What mathematical constants are available in Rust? Rust has many mathematical constants built in for both 32-bit and 64-bit decimal numbers. These include pi, which is the circle constant, and tau, which is 2 times pi. You also have the number e, the square root of 2, and various logarithm values like the natural log of 2 and the natural log of 10. Question. Why can't you sort a list of decimal numbers in Rust using the regular sort method? Decimal numbers in Rust don't implement the full ordering trait because of a special value called NaN, which stands for not a number. The problem is that NaN is not equal to itself, which breaks the rules for normal sorting. Instead, you need to use a special comparison method called total CMP, which handles NaN values in a consistent way. Question. How can you use decimal numbers as keys in a HashMap in Rust? You can use a helper crate called ordered float to use decimal numbers as HashMap keys. This crate wraps your decimal numbers in a special type called ordered float, which handles the NaN problem properly. This allows you to insert and look up values in a HashMap using decimal numbers as keys. What common mistakes should you avoid when working with decimal numbers in Rust? There are several common mistakes to avoid. First, don't compare decimal numbers directly for equality because of rounding errors. Instead, check if the difference is very small. Second, don't mix 32-bit and 64-bit decimal numbers without converting them first. Third, don't assume 32-bit decimals are faster than 64-bit ones on modern computers. And fourth, be careful with comparisons because the special NaN value can cause unexpected results. Question. How does converting decimal numbers to whole numbers work in Rust? When you convert a decimal number to a whole number using the as keyword, Rust uses saturating conversion. This means if the number is too large for the target type, it becomes the maximum possible value. If it's too small or negative, it becomes 0. For the special value NaN, it also becomes 0. You can also round the number first using methods like round, ceil, or floor before converting it. Question: what should you know about the Boolean type in Rust? A Boolean in Rust can be either true or false. Even though it only stores one bit of information, it actually takes up one whole byte of memory. You can get a Boolean value from comparisons, like checking if one number is greater than another. Question: what Boolean operations are available in Rust? Rust has several Boolean operations. The logical and or operators use short-circuit evaluation, meaning they only evaluate the second value if needed. There are also bitwise versions that always evaluate both sides. The not operator flips true to false and false to true. The XOR operator, which stands for exclusive OR, returns true when the two values are different. Question: how do you convert between Booleans and numbers in Rust? Converting a Boolean to a number is easy using the as keyword, where true becomes 1 and false becomes 0. But you cannot directly convert a number back to a Boolean. Instead, you need to use a comparison, like checking if the number is not equal to 0. Rust also provides helpful methods like then and then sum that create an option value based on a Boolean condition. Question: what common mistakes do people make with Booleans in Rust? People often make 3 common mistakes with Booleans. First, they write redundant comparisons, like checking if a Boolean equals true, when you can just use the Boolean directly. Second, they forget the difference between the logical AND operator, which stops early, and the bitwise AND, which always checks both sides. Third, they assume Booleans only take one bit of memory, but each Boolean actually uses one whole byte. Question: what should you know about the character type in Rust? In Rust, a character is always 4 bytes in size and can store any Unicode value. This means you can store letters, Chinese characters, emojis, and heart symbols. Each character represents a single Unicode scalar value, which excludes certain invalid codes. Question: how do you write character literals with special meanings in Rust? You write character literals inside single quotes. For special characters, you use a backslash followed by a letter, like \n for new line and \t for tab. To write a backslash itself, you use 2 backslashes. To write a single quote, you use backslash followed by a quote. For Unicode characters like emojis, you use \u with curly braces containing the code. Question: what methods can you use to inspect and change characters in Rust? Rust provides many methods for working with characters. You can check if a character is a letter, a number, uppercase, lowercase, or whitespace. You can also convert case, but be careful because some characters, like the German sharp sign, become 2 letters when uppercased. You can also get the numeric value of a character and create a character from a number, though some numbers, like surrogate pairs, are invalid. Question: what's the difference between characters, bytes, and how strings are stored in Rust? A Rust character always takes 4 bytes and stores a Unicode value, while a byte is a single number from 0 to 255. When working with strings, you can iterate over the actual characters, which handles multi-byte characters correctly. Or you can iterate over the raw bytes, which shows how the string is actually stored in memory. You can also get both the byte position and the character at the same time. Question: what common mistakes do people make with characters in Rust? People often make several mistakes with characters. They confuse single quotes for characters with double quotes for strings. They forget that a character is always 4 bytes, not 1. They try to directly index into a string to get a character, which doesn't work. They assume converting to uppercase always gives 1 character, but some, like the German sharp S, become 2 letters. And they try to do arithmetic on characters like in C, which you can only do safely with ASCII bytes. Question: how does Rust figure out what type of variable should be? Rust is smart about guessing types. When you write a plain number, it assumes 32-bit integer. For decimal numbers, it assumes 64-bit. It can also figure out types from how you use a variable. Like when you add a byte to a list, it knows the list holds bytes. But sometimes Rust needs help, like when parsing text to a number.
you need to tell it what type you want. Question: how much memory do different types use in Rust? Each type in Rust has a specific size in memory. Very small numbers take 1 or 2 bytes. Regular numbers take 4 or 8 bytes. And very large numbers take 16 bytes. Decimal numbers take either 4 or 8 bytes. A Boolean takes 1 byte, and a character takes 4 bytes. The usize type, which is used for sizes and indexes, takes 8 bytes on 64-bit computers.
Question: how do you convert text into numbers and other types in Rust? Rust can parse text into many types using the parse method. For numbers, it handles regular numbers, hexadecimal, binary, and octal. For decimals, it can also parse special values like infinity and NaN. For Booleans, it only accepts the words true and false. For characters, it accepts a single character string. Always handle parsing errors properly, since the text might not be valid for the type you want. Question: how can you control how numbers and other types are displayed in Rust? Rust gives you many options for formatting values. You can control width and padding, add leading zeros, and show numbers in binary, octal, or hexadecimal. For decimal numbers, you can choose how many decimal places to show and use scientific notation. The debug format adds quotes around characters and strings, while the normal display format does not. You can also see the exact binary representation of decimal numbers. Question: what's the difference between const and static for fixed values in Rust? In Rust, const and static are both for fixed values, but work differently. Const values are copied everywhere they are used and don't have a fixed memory location. Static values have a fixed memory address and live for the entire program. You can also create constants using functions that are marked as const, which run at compile time. Question: what traits do different scalar types in Rust? All scalar types implement basic traits like copy and clone. Numbers support math operations like add and subtract. Integers also support full equality and ordering, and can be used as hash keys. Floats only support partial equality and ordering because of NaN. Booleans support logical operations. Characters support equality and ordering. When writing generic functions, you need to specify which traits you need. Question: how can you do more advanced generic math with numbers in Rust? For more advanced generic math, you can use the num crate. It provides useful traits like num for basic math, 0 and 1 for getting 0 and 1 values, and traits for converting between number types. This lets you write functions that work with many different kinds of numbers. Behavior summary. Casting rules table.